Hello everyone. So welcome back to my channel. So in our last video we have discussed about how to work with the data in a Spark data frame, right? So in this video we are going to discuss uh, working with the data using Spark SQL. Okay. So the data frame API is a part of Spark library named Spark SQL, which enables data analysts to use SQL expressions to write, query and manipulate the data. Okay, so we have around four APIs, right, for writing our code in four languages basically in the notebook. So the first is PySpark, then we can use Spark SQL, and then we could use Scala, and then Spark R, right? Uh, so the data analyst or the data engineers who are comfortable with any of these languages, they can write their code with any of these four languages, right? So the Spark catalog, so creating database objects in the Spark catalog. So what is a Spark catalog? So basically, the Spark catalog is a meta store for relational data objects such as views and the tables, right? So in this meta store, we can create views and tables, and then the Spark runtime can use this catalog to seamlessly integrate the code written in any Spark supported languages with SQL expressions. So what they are trying to say is, see, in catalog, in Spark catalog specifically, we can create tables and views, right? And then there are two kinds of tables that can we can have there. So one is managed table and another is external tables, right? So uh, in managed tables, we have two things in a table, right? So one is the schema of the table, meaning that what all columns do we have in a table, what is the data type of those columns. So all this information is called the metadata of a table, right? And then the second part of a table is the actual data that we are taking. I mean, the actual table of the actual data of the table, right? So in managed table, both the metadata as well as the underlying data is there in the catalog itself, right? It is the data is also associated with the catalog. But in case of external table, we are only keeping the metadata of the table in the catalog, but the underlying data is somewhere outside. It is not there. Okay, so the table, underlying data can be in the files folder of in if we are talking about Microsoft Fabric, and then suppose we are keeping the data in the file. So that external source can be that file also, or it can be somewhere else as well, right, in the cloud. So but the metadata will be inside the catalog. And then how can we identify that whether it is a metadata, if it is a meta managed table or an external table? So see, you can write a command. You can check by writing that command. Maybe when we will be doing the lab part, right? There we can see that how we can just uh, just give this command, right? Describe and then the table name. There we can see that whether the table is a managed table or an external table. And also, if you drop a table, the if you're dropping a managed table, then the metadata and the underlying table will also be dropped. Okay, because the data is also there. But in case of external table, if you are dropping an external table, only the metadata of that table will be dropped, but the underlying data will still be there. So this is the difference between the managed table and the external table, right? So that was about the managed and external table. Let's come back to the Spark catalog that we were discussing, right? So see, we have a table, and then if a user really wants to work on it, what they generally do is they create a temporary view on top of the table. Okay, So here what we are trying to do is we are creating a simple temporary view in a data frame basically. So if you can see that this df, this was the data frame. Just think of it as that we have created any data frame. We are reading a file from some source, and then we have created a data frame. Now in order to create a temporary view, this will be the method that we are going to use, right? So what we are doing here is we are just creating a temporary view and naming it as a products view. Okay, so see over here it is written a view is a temporary, meaning that it is automatically deleted at the end of the current session. So once your session is ended, this temporary view will also be dropped or deleted, right? So you can also create tables that are persisted in the catalog to define a database that can be queried using Spark SQL, right? You can create a table as well there. So tables are metadata structure that stores their underlying data in the storage location associated with the catalog. In Microsoft Fabric, data for managed tables is stored in the tables storage location shown in your data lake, and any tables created using Spark are listed there, right? So this, they are talking about the managed tables where we have the underlying data there itself, right? So it is associated with the catalog, right? And how we can create a metadata, the managed table where we have the underlying data within the catalog itself. So you can create the table, an empty table basically, using this method spark.catalog.create table, or you can save a data frame as a table by using save as table method, right? Deleting a managed table also deletes its underlying data, right? That we have discussed already. Now, for example, the following code saves a data frame as a new table named products. So here what we are doing is we are writing this method df is the data frame that we have already created from where we are reading the file, and now we are trying to save it, right? So df.write.format is delta, and then save as table, and then the table name with which we want to save it. So here we are saving it as products, right? So the Spark catalog supports tables based on files in various format, right? And then the preferred format in Microsoft Fabric is delta. So we are writing the data in a delta format, which is a format for relational data technology on Spark named Delta Lake, right? So it supports features commonly found in relational database systems, including transactions, versioning, and support for streaming data, right? Additionally, you can create external tables by using spark.catalog.createExternalTable method. So using this method, we can create an external table where our underlying data is not in the catalog but stored somewhere else. But here we have to specify the storage location where the actual underlying data is kept, right? So that it can refer to the actual data. And here by creating this, we are creating only the metadata of that table, right? So external tables define metadata in the catalog but get their underlying data from an external storage location, typically a folder in the file storage area of a lakehouse. Deleting an external table doesn't delete the underlying data, right? So um, we can apply the same partitioning techniques to delta lake tables as discussed for the Parquet files in the previous unit, right? So we have discussed this partitioning concept earlier in our previous video. So in a just to recap, so so while writing these tables, right, what we can do is we can partition the data basically, so that while reading the data it will be performant. So what we are doing here is we are partitioning our table based on certain columns which has low cardinality, meaning it has less number of unique values, right? Just for an example, just take an example of this product table itself. So in this product table we have one column named category, and then in this category we are categorizing our products based on the category of the product, So right, so there are just take an example that there are two categories only: mountain bikes and road bikes, right? So we can partition our table, this product table, based on the category, which what it will do is it will create it will just write the data under these two separate folders of so one is will be mountain bike. So whatever the data which is related to mountain bike will be kept in that folder, and in another folder which will be the road bike, another folder will be created, and all the data which is related to the road bikes will be kept there. Now during um, reading the data, and since we will be giving this suppose we are putting a where clause condition wherein we just want to see the data for road bikes, there we can put that condition, and then the query will be faster because it doesn't the query doesn't have to go to any of the other folders, but it will only hit this road bikes folder, right, where the data is actually kept. So it has there will be less input output operation, and then the query result will be faster, right? And since we are talking about the big data, the performance will be greatly improved in this case, right? And then the it will be real fast. So yeah, partitioning is very important while writing the data in delta table, right? Cool. So so here what we are doing is using the Spark SQL API to query the data, right? So we can use Spark SQL API in code written in any language to query data in the catalog, right? So what does it mean? See here what we are doing is this is the Python cell. We have this is the default language of this cell is Python, right? But what you can see here is we are writing the code in SQL, a different language, right? So what we are doing here, this Spark SQL API, this Spark.sql is Spark SQL API. So we are using this API so that we can write the code in our simple SQL language, right? So this is what we are doing here, right? And then yeah, we are just displaying the data. So this is where it is showing us the data. So using SQL code, the previous example demonstrated how to use Spark SQL API to embed SQL expression in Spark code. In a notebook, you can also use magic SQL, this percentage SQL, this magic expression, and then you can run the SQL code that queries the object in the catalog, right? So what we are doing, we can just change the language using this magic command, and then we can simply write the SQL query and then query the data, right? So and then it will give us the result based on whatever query that we are running, right? So let's go to the next next unit. So visualize the data in Spark Notebook. So uh, so one of the most intuitive way to analyze the result of data query is to visualize them as charts, isn't it? So notebooks in Microsoft Fabric provide some basic charting capabilities in the user interface, and when that functionality doesn't provide what you need, you can use one of the Python graphic libraries to create and display data visualizations in the notebook, right? So if you see here, uh, so this is our Microsoft Fabric workhouse where we have we are inside, we have opened a notebook, and in that notebook if you have written a query, suppose, and then here in the table section you can see the table or the data in a table format, but if beside that you can see the charts, right? So in the if you go to the chart, the same data you can see that data in the visual format, and then in this example, and on the right hand side you can select the chart type, that what chart type you want to see the data in. So here we have selected this pie chart, and then there are other um, fields that we can select. So we have key values, and then depending upon whatever chart that you are selecting, so based on that those values will be coming up for you for your selection. So you can select and then you can visualize the data whatever is there, right? So this capability is there. So there are some default chart which are already given there. But in case you want to see the data in a different in with the different visuals, so you can use the already built libraries that we have, and then you can use matplotlib library, and you can plot your own graph there, right? So here in this example, what we are doing, we are just importing certain I mean this pie plot from this matplotlib library, and then we are putting the data, whatever data that we want to display, in one of the data frame, and then we are just plotting that data using certain you know this code. So we have using this code, and we are just customizing the chart based on our requirement. So this is how it will look like here, right? So all this thing can be done here. Now let's move on to the next unit, and then it will be a practical exercise that we are going to do here. So we will go through this exercise wherein we will be working with Apache Spark in Microsoft Fabric, right? So we will be using Spark Notebook to analyze and visualize the data. So let's launch this exercise. So we will quickly start by creating a Microsoft Fabric workspace, right? So we are creating a workspace before working with the data in Fabric. Create a workspace with the Fabric trial enabled. Okay, and then yeah. So what we are going to do here is, first of all, we will go to Microsoft Fabric, right? And then we will go to data engineering workload, and here we are going to create a workspace, right? So better we can go to workspaces, and here we can create a new workspace, right? So before doing anything, we need to create this workspace, right? So whatever files or tables that you are going to create, you should be doing that after creating a workspace. So let's create it. So yeah, we are creating a default workspace. The name should be unique. See, it is saying here that this name is available. Fine, so we can go with it, and then we can simply apply it. Right, so it will take some time to create the workspace, and till that we can see that, okay, next what we have to do. So we have to create a lake house, and then we have to upload the file, right? So yeah, so our workspace has been created. Next what we are going to do is we have to create a lake house, right? So we have to create a lake house because once we have to save all our tables, right? We have to save our delta tables also there. So for that we need to create a lake house. So that's what we are doing here next. Yeah, so it will take some time, I think. We will wait. So we can create a test lake house over here. Okay, it is already existing. So we can create another, maybe. So our lake house has been created. As we can see that there are two folders now. One is for table and another is for file. So what we can do is we can, here we have a link for the test files, right? So we have we can go, and then we can simply use these files. We can download it in our local, and then from there we can upload these three files in our uh, files. So we can go to the files, we can upload the folder, right? So we can I have already downloaded these three files. We can select the, okay, we can simply upload this folder itself. So yeah, it took some time, it will take some time to upload, but yeah, it was quick because the file size was less. So we can see that this order folder is already there, and then we have all the three files over here, right? So yeah, so what next we are going to do is, we can you can follow the documentation, right, in the Microsoft Learn, and I will simply follow the same steps, right? So in the open notebook, what you can do is, you can go to the new notebook, and you can create a new notebook over here. Yeah, so here, you can use it as a cell for running your cell, or you can also use it as a markdown cell. So here, you can put any comment that you want to do. So you can put sales order. What we are doing sales order exploration. So we can type this, and then we can uh, you know make it as a markdown cell. Yeah, so I think I have to refresh this. Okay, so I think something is not right, because it is not showing it properly. So yeah, now fine. I think it is not showing properly, but we'll find out later. Maybe we can continue with our exercise, right? So what we are going to do is, yeah, so we can load the data. uh, so we can go to any of these folder, and then so we can go to the 2019 .csv file, and then we can load the data into the Spark. So what we are going to do is, so if you go on the left hand side, you can see this lake house, right? So you can, if you click on it, you will see your orders folder, and then once you click on orders folder, you can see all these three files. So you can go to this three dots, and then you can load the data into Spark, right? So the data has been loaded over here, and then you can simply run this command. Yeah. So I think here why it didn't work is there was no space in between this. So yeah, so now it should be good. So we are good over here now, right? We can, okay, we can delete this cell. It was redundant. So fine. So the last command that we have executed, so it is executed, and then we can see the data over here. As we can see here, the first cell is shown in this column names. So in this file, we don't have the column names. So then what we can do is, in the options, we have put this header as true, right? So we can turn it as false, and then we will execute this. So this will since we don't have the header, so what it will do is, it will give us the default header names, so c1, c2, c3 and all. But we don't want this, right? We want the proper column names should be there. So what we will be doing is we will specify explicitly the column names and also the data types for those columns. So if you go to the documentation, there you can see uh, here you can see that what we are doing is we are first of all we are importing certain SQL types, okay, from the library, and then we are using this method struct type method, and using this struct type method under the method struct field, whatever column names that we want to give, right, that we can mention over here, and then the data type that we want for those specific columns, and then we are putting it in a then we are reading this uh, file, okay, from the location, and also the schema we are explicitly specifying it. So dot with dot schema method uh, we can implement it, right? So this order schema we have put it in the order schema, and then we are mentioning it over here, right? So we can copy this, and we can run over here, right, and we can execute it. Okay, so you can see that we have the column names with the proper data types now, right? Yeah, so next what we can do is, so now the data frame includes the correct column names in addition to the index, which is a built-in column in all the data frames based on the ordinal position of each row, right? So data types of the columns are specified using a standard set of types defined in the Spark SQL library, which were imported at the beginning of the cell that we have already seen, right? So here, yeah, what they're saying is in the data frame we were only including 2019.csv file. So instead of that, what we can do is we can use the wildcard, so that in the orders folder it will use all the files which are there. Okay, so all the CSV files we can simply move it. So see, earlier it was 2019, so once we run it will take all the files over there. So here you can see now the 2021 is also there now. Okay, so next let's move on to the next part. So here what we are doing is we are exploring further, and here we can do the transformations, right? We can filter the data, we can manipulate the data by taking only the specific columns that we want, and then we can see, we can just you know uh, group the data, we can do the count of the data over in the on the data frame, and then yeah, we can do all such you know uh, transformations. So just to give you a view, we can go to the code and we can simply paste it and then execute it, right? So yeah, you can see the count of the customers, the distinct count, and the list of the customer, the distinct customer. So this we can do. So here what how we are the syntax that we are using here is the data frame, whatever we have, and then in the bracket with the single quotes we are giving the column names that we want to display, that we want to include in this data frame, right? So another syntax would be we can use select. So df dot select, and then in the bracket under the double quotes we can give all those column names, right? So here, and then with the dot we can give further we can further modify it using different methods that we have. So here we are using where condition, and then only filtering the data for which the item, there is a specific item, right? Similarly, we can do the aggregation of the data by using this group by function, right? So here we are just doing the order by we are just taking the yearly data over here. So for this, what we are doing, we are just importing certain functions, SQL functions, and then here we are utilizing this year method and taking and then we are using this COL, which stands for the column. If you want to just call out any column inside any method, and then here we are taking the order date and taking only the year part of this year order date and making the alias of it column of this column as year, right? And then we are grouping it uh, and then displaying the results, right? So here if you can see that a common task for data engineers is to ingest the data in a particular format or structure and transform it further for downstream processing or analysis. So this is what we are doing. So we are transforming the data, right? So if you see here, the base data frame, whatever we have in that base data frame that we created earlier, there we are adding few more columns. So we are adding an year column, right, with this syntax, and we are also adding month column over here. And then in this transformed data frame we are adding further, we are adding first name and the customer, okay, and then yeah, we are splitting the customer name, right, and then we are only taking the first name from it, okay, and then yeah, first name and last name, right, and in here we are just reordering the column names, right, and then we are simply displaying it. So we can copy it and then we can run it as well, right? So let's clear the output and we can copy it and then execute it, right? So you can see it here. So next what we are going to do is we have this transformed data frame. Now we are going to save it, right? So we can save it in a Parquet format. So here we are trying to save this data frame in a Parquet format now. Earlier it was in CSV format. We want to save it in a Parquet format, right? So we can simply execute it. So what it will do is we have given a specific location. So under the files we have given transform data, and then in so this is another folder that will be created. So if you go to the files, you can simply refresh it, and then you can see this transformed data folder over here, okay, and inside this you can see these orders folder, and inside that order folder you can see these Parquet files already been written over there, okay. Yeah, and now here we are just simply reading this these Parquet files. So I think this once you will do your lab, right, you can do it for yourself. Here what we are doing is we are partitioning this data now. So we are partitioning this data based on the year and month, right, and then saving it again in a Parquet format, right. So partitioning, once you do the partitioning, right, it will create the separate folders for years and the months. So inside the years you will see all the months, right. So this is just for your to optimize the performance while reading this data. So in whenever we have huge amount of data and we are reading the any specific data, right, so it will, instead of going to all the folder all the entire table, it will go to those specific folder where our data is actually residing. So that way it will make our query performance really fast, right. So I think you can do this exercise for yourself, and once your data is there in the partitioned folders, right, you can query the data using this this way. I mean, in this load, you can give the path where files partition data, and then you can specify the specific folder that you want the data from. For example, if you want 2021, all the months of 2021 year, so you can specify like this, right? So once you do this, uh, you, and in the data, you will see that those column names for which we have the folders, right? So those will not be shown in that table, because in that case it is quite evident that okay, you are seeing the data only for 2021, right? So that way, so this is what they are telling. So in the note that the partition columns specified in the path year and month are not included in the data frame, so that you can check it for yourself, right? So now working with the table. So we have discussed about managed tables and the external tables, right? So managed tables where we have the underlying data in the meta store itself. So this is what they wanted to show us. So uh, let's we can do one thing. We can create this table, and then with this describe extended sales for, we are describing that table, right? And there we can see that whether it is a managed table or external table, right? So yeah. So one thing also, so here we are simply saving this file, this data frame inside this table, and we are not explicitly specifying any location. So this is also one of the thing. While creating a managed table, we don't specify the location because it will save in the default metastore location. But in case of external table, we have to explicitly specify the location where we want to save that table, right? Sorry, we have to specify the location so that it can refer to the underlying data. So when we create an external table, it will only write the metadata of that table, but the underlying data is kept at another location, right? So see, we have executed this command, and then here we can see this type is managed table, right? Yeah, right. So what they're telling is, if you want, this is all in Python that we are writing, and with this Spark.SQL we can write in the Python notebook, we can write using SQL command, right? As you can see over here. But if you want to write your query in SQL way, so in SQL statement, so you can use this magic command. So percentage SQL, and then you can write all the commands, sorry, all the statements in this SQL way, right? And here you can visualize the data, right? So if you go to the notebook and go to any of the tables, so if you see this data, right, beside that we have a chart. This chart will give you a good overview of your data. So I think we are just limiting the data, that's why it is showing it like this. Let's check this one out. So here you can see the default charts, whatever. Here we can customize this chart also, and then we can have a good idea of our data, whatever the data that we have. You can select, you can change the data, the chart type, right? And then whatever values that we want to select, and then you can simply apply, and then you can see the data right over here. So this way you can do. So I think we have covered pretty much what we have in this exercise. I hope you would have taken away from this session, you know. So you can do this exercise for yourself, and then if you have any doubts or any queries, please put in the comment box, and I will definitely come back to you. Thanks for your time, and have a good day.